Hello, we're the Keweenaw Rocket Range, and we are submitting in an application to join the Argonia competition of 2024. We have previously participated in 2022's Argonia competition with a unsuccessful payload deployment, and we have since learned the failures and shortcomings of our previous rocket and are going to try to improve on them in this next launch. The Keweenaw Rocket Range was founded in 2018 as a student organization at Michigan Tech. Our first competition that we attended was in 2019 and we went to IREC. At IREC we successfully reached the altitude cap, and then around the second year that we attempted to go to IREC, something happened called COVID, which kind of shut down our organization for a solid several months, which resulted in a gap that we were trying to rebuild ever since. Coming up on this next year for Argonia, I feel like we have regained a lot of the knowledge that we have lost previously for the past 2 years of the Keweenaw Rocket Range, and are ready to do a successful flight here this year. I'm Riley Van Zeeland. I'm a third-year mechanical engineer, and I am the president of Keweenaw Rocket Range.
I'm Julia Petrine. I'm a third-year mechanical engineer, and I'm the vice president of the Keweenaw Rocket Range.
I'm Teresa Tomasino, fourth-year mechanical engineering major, and I'm the secretary of Keweenaw Rocket Range.
I'm JJ Berg. I'm a first-year mechanical engineering major, and I work on the payload for the rocket.
I'm Colin Reeves. I'm a freshman mechanical engineering major, and I'm helping out with the recovery gear for this year's Keweenaw Rocket Range.
I'm Jason Edwards. I am a first-year computer science major, and I run the social media for Keweenaw Rocket Range.
The competition that Argonia Cup has created this year is launching as many golf balls as we can, as high as we can, in a 2-stage rocket.
We are going to have 3 stages of testing for our rocket. The first stage is a simulation where we determine how high we expect to go. Our second stage of testing is going to be a ground ejection testing, where we make sure that all our altimeters work and we make sure that our charges have been correctly calculated. And our final stage is going to be a test launch, where we're going to be doing the testing or staging. We're going to have slightly lower powered motors because of the lower altitude cap, but we are going to have a very similar flight profile.
To achieve our goals in the Argonia competition, we decided to build a 4-inch diameter rocket to carry as many golf balls as we can. We chose to buy a Lock Precision Black Brown X kit to accomplish this, and are making it more of a custom rocket by fiberglassing the body tubes and changing out the motor mounting to accommodate a second stage.
The payload of the rocket is going to be consistent of golf balls stacked about 18 inches high, and the way that you can maximize the amount of space is in the 4-inch diameter rocket is that you can stack 3 golf balls in a ring and then alternate those rings going up for about 18 inches to maximize a golf ball hold of about 36 golf balls.
Alright, so for our control systems, the big thing is redundancy. So on every stage we've got a pair of batteries, each of them are independent of each other, and a pair of altimeters. On the first stage we're using 2 of these MissileWorks altimeters, on the second stage 1 of these and 1 of these featherweight altimeters, just to save a little bit of space. On each stage we also have a self-contained GPS that allows us to actually find them after they go up however high they're going and come down whoever knows how far away.
This is our simulation for the rocket. We expect it to achieve an altitude of 14,000 feet. We'll be flying on an L1090 white Aerotech reload and a K270 white reload for the second stage. We expect it to see a max acceleration of 109 meters per second squared and a max velocity of 271 meters per second, or Mach 0.82.
Thank you for watching, and we look forward to seeing you at Argonia in March.